Hi everyone, Matheus de here, and on this video I'm going to show you a little bit about block validity rules or block validity policy and how stakeholders could strip the rewards of miners by voting a block by voting the regular transaction tree of blocks as invalid. Okay, so on last video I showed you how to set up simnet. I've got a simnet set up here already up. I'm at block 330 and I'm going to simulate a little bit just to show you how uh, the network behaves while blocks are not being voted invalid or while the regular tree transactions aren't being voted invalid. And then I'm going to show you how to change the wallet to follow some policy that stakeholders could decide upon to vote a block as invalid. And then I'm going to show you what happens when a specific block is voted as invalid. Okay, so I'm at block height 330. Let's just mine a block here, see if everything is okay. So 331. This is the hash of the last block here. Let me quickly copy it here. Let me pick up the get block. 331. Okay, so this is the block. Vote bits is 1, so this block is voting that the previous block 330, is valid. Let me quickly check here. This is the coinbase for block 331. Let me mine a couple more blocks. Coinbase, it has 3 confirmations, so everything seems fine. And let's just also do a small transfer. This is a transfer I've made on the wallet. So 7AA65. Let's mine a couple of blocks. So 334. Let's see block 334, and my transaction is right here. Okay. Let me just check here. So no confirmations yet. So let's mine a couple of blocks. 3 confirmations. So this transfer is confirmed. Okay. So we're going to now. So this is what usually happens during regular operation of the credit network. Okay. We're simulating here on SimNet, but this is essentially what's happening on mainnet and testnet as well. Okay, so now let's say that uh, the stakeholders have decided to block a particular miner, or they have decided to enforce some policy for stripping miners of their rewards, but this policy is not enforced by consensus rules. This is a soft policy. This is maybe a political uh, policy, or a policy that, for example, it's been found that a given miner is censoring transactions or is trying to create blocks that are too small, or any given policy that stakeholders could agree upon. And we are going to enforce a very simple policy, which is that we're going to vote false on all blocks at height ending in 5. Okay, so for example, we're going to, whenever we find a block at height ending in 5, we're going to vote. We're going to issue a vote on that block as false. Okay, this is a very simple policy just to show you what's happening here. I'm at the wallet, the Sierra wallet code. There's a, if you go looking for it, you're going to find a function called vote on owned tickets, which should be pretty self-explanatory what it's doing. I've added a couple of debugs here, but basically what we're going to do is that, sorry, if we find a new block for which we have tickets to vote on, and this block is height mod 10 equals 5. So if this is a block ending in a 5, so block 335, 345, 355, we're going to vote false on this block. And this little bit here, this line is what actually issues the vote on the block validity or on the validity of the regular transactions as false. Okay, if you go look at this structure right here, this vote bits, it has 2 bytes. Okay, so it's an uint16, so there's 2 bytes here, and there's an extended bit field that could be used in the future to vote for more things. Okay, but basically we're only going to vote on regular transaction validity. Okay, so I've saved here, so let me rebuild the wallet. Okay, so now I am going to go into my wallet and stop it, restart it. Okay, so let's now mine a couple of blocks. I'm at height 336. 337. You can see here how the wallet is voting on a given block. Okay, let's mine a couple more. 9, 10, 340, 41, 42, 43, 44. So on block 44 wallet, the wallet is still sending bits as 1. So let me quickly do something else here. I'm going to send a transfer on this block. So block 344 has just been mined, and the next block that is going to be mined is going to be block 345. Okay, which the wallet is going to, so this transfer here that I just sent, 38D, is going to be inserted, is going to be included in block 345. Once block 345 is mined and relayed on the network, the wallet is going to detect this block. It's going to see that it's a block ending in 5 at a block height ending in 5, and it's going to vote false on this block. So that when block 346 is mined, then the votes included in block 346 are going to be votes voting false on block 345. Okay, hopefully that's reasonably clear what's going on here. So let's see here. Let's mine block 345. So we can see that the wallet is voting false on block 345. And now I am going to vote to mine block 346. and the wallet has voted true or voted validating the regular transactions of block 346. Okay, so let's now see what's going on here. So let's see block 344. It's right there. Okay, so vote bits 1, transactions there. Let's see 345. You can see that my transaction, my transfer has been included on this block. Let's just double check the hash here. It's 3E8D. 3E8D. So this transfer right here is included in block 345. Okay. Block 345 has is setting vote bits as 1 because the votes that were voting false were cast for block 345, not in block 345. Okay, so let's now see block 346. So this one is the one that has vote bits 0. Okay, so it's stripping block 345 of the rewards. And did I mine? Okay, let's mine one other block, 347. And now watch what happens on block 347. Look at this transaction right here. So this is the transfer and it's appearing again in block 347. So this transfer is appearing 2 times in the blockchain, which would usually be double spend. But since we voted block 345 as false, the transactions included in block 345 have been invalidated, have been rebroadcast or re-put into the main pool, and they are free to be mined again. So let's double check here. So block 345, okay, so look here, the command that I just issued. Block 345 has the transaction here, transfer here, 3E8D, and block 347, you're going to see the first transaction here. The Coinbase is going to change. And this one is also including the same transfer, the same transaction, okay? And just to double check on the Coinbase rewards, let's see, get the X out. Let's see, this is on block 347. So let's see here. This is right here. Let me mine a couple more blocks. Has 3 confirmations. And now let's see on block 345. This is the Coinbase of 345. It's not known to the network. Okay, so this Coinbase, so get tx out is the command that is going to try to get an utxo, okay, an unspent transaction output, and the network does not know about the Coinbase or does not recognize the Coinbase of the invalid block as an unspent transaction output. So the miner effectively cannot spend this transaction or this output. Okay, so that's basically how regular transaction block validation works or block voting works on Decred. Okay, so see you next time.